Hello dear students, this question is from 2012 exam. It's for 2 marks. Let me read out the question for you. A computer system has 256 KB 4-way set associative write-back data cache with block size of 32 bytes. The processor sends 32-bit addresses to the cache controller. Each tag directory entry contains, in addition to address tag, 2 valid bits, 1 modified bit, 1 replacement bit. The number of bits in tag field of an address is. Okay, so this is a 256 KB write back cache. What is the meaning of write back cache? Caches can be of two types, write through and write back. Write through means, say this is your CPU. Whenever CPU tries to write something into the closest level of cache, that means L1 cache, that change will be done in L1, L2, L3 as well as the main memory. Okay. But in case of write back cache, that change is done only on the closest level of cache. Okay. If we have 3-level cache, any change that CPU does will be done only on L1 cache. Okay. And when will that change propagate to higher levels of cache or main memory? Only when we want to replace that block from L1 cache. Okay. That's the reason we maintain these bits, valid bits, replacement bits, and modified bits. Modified bits tell us that whether or not this block has some dirty data. Okay. If something is updated, we call that block as a dirty block. Whenever we need to replace that block, all the changes have to be propagated to the next level. Okay. So first let's solve this question. Then we'll discuss more about these things in second part of this question. It's actually a 4 marks question. 2 marks for each part. So they're saying processor sends 32-bit addresses. That means physical address has to be of 32 bits. Okay. Also, they've mentioned in question that block size is 32 bytes. If block is 32 bytes, how many bits will be there in block offset field? 5 bits, because to identify one of 32, we need 5-bit address. Okay. Now, next thing is, let's find out how many bits will be there in set number. But before it, you obviously know that this is how we divide physical address in case of K-way set associative mapping. It is tag, set number, block offset. Block offset identifies one word within a block. Set number identifies one set from the cache. That means to know how many bits is this data or this set number field, we need to know the total number of sets in cache. For that, we'll use this information, and this information. Okay. First of all, let's find how many blocks will be there in cache. Number of blocks in cache. This will be the total size of cache by size of one block. Size of cache is 256 KB. One block is 32B. Okay, so this one comes out to be 2 raised to the power 18 divided by 2 raised to the power 5. Hence, we have 2 raised to the power 13 blocks in cache. Now, saying that 4-way set associative cache mapping is used means we have 4 blocks in one set. Total number of blocks are these many. how many sets will be there? Let's find it out. Number of sets in cache will be total number of blocks by number of blocks in one set. So total number of blocks in cache are 2 raised to the power 13. Number of blocks in one set is 2 raised to the power 2, which is 4. So this comes out to be 2 raised to the power 11. Okay. That means set number field is of 11 bits. Now total is 32 bits. From 32, you subtract 11 plus 5. And obviously, you will be left with tag field bits. That means tag will require 16 bits. Answer to A part is 16 bits. Okay. And the split for physical address is 16 bits for tag, 11 bits for set number, 5 bits for block offset. Now we'll just see the second part of this question. Second part of this question is asking the size of cache tag directory is, and they have given you 4 options. Let's try to solve the second part also. So now you know tag is of 16 bits. Also, they have mentioned along with this tag field, we are saving 4 additional bits. That means a 16-bit tag is saved. Also, we are saving these 4 additional bits in the tag directory for every tag. That means total 20-bit value is saved for every cache line. 20-bit tag, which comprises of 16-bit address and 4-bit metadata, is saved for each cache block. So tag directory size, I'm writing it here. Tag directory size will be equal to number of cache blocks into size of tag this size of tag is 20 bits. Don't take only 16 bits because actually while saving we are saving 4 bit of extra information. So this comes out to be 2 raised to the power 13 into 20 bit. This is your answer. So maybe they are asking in terms of k bits. Okay, so let's first separate k from here. 2 raised to the power 13 can be written as 2 raised to the power 3 into k. Okay, this k can be written, 2 raised to the power 13 can be written as 2 raised to the power 3 into 2 raised to the power 10. Okay. So this one comes out to be 8 into 20, which is 160 k bit. So your answer is 160 k bit. Tag directory size is 160 k bit. Also, how can I write this formula? Just remember, for each and every cache line, we have some tag bits. Okay.